Yeah, and it's so cold, hey?
Yeah.
Very cold.
No, as long as you guys are surviving, yeah. All right, let's see. Did we record the session? Yeah, okay. Great stuff. Okay, so let's just go through this assignment 2. Okay, this is basically binary to decimal. You guys know how to do this one. This is octal to hexadecimal. We looked at this, but you must check the marks. You can see the marks is 18 marks, so it wants effort. I'm not gonna comment on it. It wants effort. This one, Boolean algebra laws. We haven't really looked at the laws. Do not use a truth table, right? The applicable law. There's exam notes 1. Exam notes 1. Have a look at that. Exam notes 1, we'll go through it. Have a look at that. Then you have your Karnaugh maps, W, X, Y, Z. We looked at the Karnaugh maps. We'll focus on another example. This ones I'm not gonna comment. I'm not gonna say anything. There. Implement the logic circuit. Let me see here. Those who attended last week or the last session, actually the last 2 sessions. I'm not gonna say anything here. Not gonna say anything here. Sigma notation, we did it. We can do another example. Sigma notation. I'm not gonna say anything here. I'm not gonna say anything here. Sum of products. Sum of products. Okay. I'm not gonna say anything here. It comes from this. Oh yeah, that's where it's coming from this. Okay. Then we haven't really looked at De Morgan's theorem. We'll just do one example. And I'm not gonna say anything here. So I can say from our sessions, it's possible to get 100%. Let me calculate. No, this 14 marks is gonna be a bit difficult. It's not difficult, but it wants you to practice. This 14, yeah, it's only this. It's only this one. But anyway, at least we have the scope of the session for today. Let's start. Let's see what we have in our units. I think you guys are on phase 8 now. Any questions or anything that you want us to focus on first?
Hello. It's Tinyiko. I hear you. You are saying that there's some of the part that you are saying that we're not gonna look into them. Was there a separate session before that where you discussed these points?
Yes, yes. There was a session where I discussed the things. So if I discuss them again, I'll be answering. So there were sessions. You see, we had sessions.
Okay. And will I be able to get those recordings?
Yeah, they are on YouTube.
Okay. All right. Thank you.
All right, all right, all right. Okay, so it's just that it's unfortunate that the what is it? The assignment is basically more or less the same examples that we're discussing. So that's why I can't discuss them again because I've seen the assignment now. So I can't discuss those ones, sorry guys. But let's see, there will be similar examples here. And now it's always easier to study from a memo. For me, I feel like it's easier to study from a memo because you can see where you go wrong or where you went wrong, right? Okay, exam preparation. So this is Boolean algebra. Boolean algebra. One's complement. No, this one is boring. Let's go to this one. Great stuff. This one is very, very, very nice. Do you see what I mean? I think you guys get me. It's very nice. Okay. BCDC. Ones, twos, complement, convert. This one. Okay. So even this one is important for your octal conversions, right? So for your octal conversions, remember what I said, octal is a group of 3, right? So now why is octal a group of 3? Let's go back to our, let's go back to our Excel draw. We have, so now we're gonna have 1, so 2 bits grouped together, they make octal, right? 1, 2, 4. So this is basically 8 in total. So now 2, if let's say 7 in octal will be 1, 2, 4. So it means a bit needs to be present here, and here present, and here present, right? Then you will have your 7. So 7 will be 111 in octal. Get my point? Let's say, so sorry, 7 in octal will be 111 in binary. Are you guys with me? Okay. So let's go back here. Let's go back to the first lesson. So we have decimal, which is a number system. It's a base 10 number system. So now what does it mean? Because I think we have a new member here. The new member, I think I've seen. So it's definitely a new member. I'm not sure about Abigail, but let's see. So now let's cater for the new members. So now what does a base 10 mean? The number systems that we know between you and me is 0 up to 9, right? We know 0 up to 9. This is what the human brain uses. That's why we teach kids this in grade 1 and stuff. So now from all these numbers here, there are 10 combinations. You need to, if you start from 0, right? If you start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These numbers, they are 10. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10. That's why we call it a 10 base system. So now that's why when you write, let's say you're writing 72, let's say you got 72%, you're writing 72, you don't need to put a base 10, right? But it simply means the 72 in decimal. Everything in decimal basically is to the base 10. Then we have your binary. Binary is to the base 2. So remember, what does a base mean? So now what does a base mean? A base mean all the possibilities that we have right here. So here we had 10, so that's why this 72 or 22, whatever this number is, was to the base 10. So now in binary, you only have 2 possibilities, right? Which is 0 or 1. So 0, it simply means it's a low, right? Low, and then 1, it's a high. But now what do you mean, sir, about low and high? High, it's simply switching on the light, right? If your light is on, if a bit is present, your light is on. Low is if it's off. Maybe it's load shedding, it's off, it's 0, right? So in binary, you have 2 combinations. So how do you see? It's 0, 1. Then you're going to have this base, base 2 for binary, right? So because there's only 2 possibilities. So now we looked at decimal. Let's write it here. Binary. Then the next one from here is it's your octal. Octal. So now octal, we know an octal, what do you call that shape? Octagon has got 8 sides, right? Octagon has got 8 sides. So it means octal is to the base 8, right? Is to the base 8. So now we know what does a base mean. It means there is 8 possibilities, right? So now here it was 0 to 9. So octal is going to be 0 to 7. 0 to 7. 0 to 7, right? It's going to be your octal. So it means it works with numbers between 0 and 7. In short, okay. Then the next one is hex. Hex is 16 to the base 16, right? So now it means with hex, okay, I need to cover something for you guys to understand as well. But in simple words, hex will start from 0, 0 to 15. But from 10, 10 is an A, 11 is a B, 11 is a B, right? B, 12 is a C, D, 13 is a what? 13 is a C, no, 12 is a C, 13 is a D, 14 is a E, 15. So I just want to put the last one. 15, it's an F, right? So let me show you what I mean. So when you're dealing with octal, I'm back to octal now, you need to group in threes. This is what I wanted to explain. You group in threes. So I had to start here so that you can understand why do we group in threes. It's because if we group in threes, the highest number here will be a 7. Do you get what I'm saying? It will be a 7. It will be this. That's why octal we group in threes, right? So now you have your hex. So for hex, you need to group in one in fours, basically. 1, 2, 4, 8, right? So if you have 1 here, 1 here, 1 here, 1 here, this will be equivalent to 15, this highest number. 15 is a F. So 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So it's 15, which is equivalent to F. So we know this is F16, right? Then, for example, what here? Okay, it's what is this one? 7, 8, right? 7, 8. But now to binary, it's 1112, for example. So this is binary as well. Okay, so now let's go back to the question. We had a very nice example here. So here they are saying, convert this to hexadecimal. So now you're gonna take the 2 like we did here. You're gonna take the 2 like we did here. So here we took the 7. So let's take a 2. You're gonna take the 2, 2. We know 2 is in binary. It's gonna be 1, 2, 4, right? I'm always using 3 bits because I said you group it into threes here, right? So now for 2, this will be a 0. This will be a 1, and this will be a 0, right? So basically 2 in binary will be like this. So it will be 0, 1, 0, right? Okay, 0, 1, 0. So let's go to the other one and see. Where were we? Yeah, we were here. Okay, so the other one is okay. They started with this one. Okay, so yeah, you start with this one anyway. 2, 5, 6, 2, right? So we know 2 is 0, 1, 0. We know a 5 is 1, 0, 1, right? We know a 6 is 1, 1, 0. We know 2 is 0, 1, 0, right? So we convert it to here first. So now this is how I prefer it. I like the easiest way out is to convert everything to binary first, right? So now after that, we're going to group everything together. So let me do it for you like this. You're not gonna be able to understand. Let me just do it for you here. Let's copy this whole thing. Okay, let's copy the whole thing. What was that? So that's 2562. 2562. 2562. 2562. 2562 octal, right? We know a 2 is 0, 1, 0. So this will be 0, 1, 0. It's for the 2, right? Then the 5 is 1, 2, 4. Let me just put it here so that I can calculate from here. 1, 2, 4, right? 0, 1, 0. Then the 5 will be 1, 0, 1, right? And then the 6 will be 1, 1, 0, 1, 1, 0, right? 6 is 4 and 2, right? So that's why it's a 1 here and a 1 here and a 0. So 4 plus 2 is 6, right? And then the 2 will be 0 here, 1 here, and a 0. So 0, 1, 0. So this is how I cheat. This is the easiest way. So now, to convert this to hexadecimal, you need to group into 4. Right? You need to group into 4s. What did I say about hex? Hex we group into 4s here. So here we group into 4s. So now we need to have, on the side, we need to have 1, 2, 4, 8, right? But now before we go there, let's just group into 4s. So this is the trick. I know we have 0, 1, 0, right? I know we have this 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0. So when you group in 4s, you start from this side. Think, what is this? The least significant bit. So you're gonna start from this side. You're gonna group your first 4 here. So your first 4 will be 1, 2, 3, yeah, 4, right? So it will be this one, 0, 0, 1, 0. That's the first 4. Then the second 4 will be this one. Agree? 1, 1, 1, 4. And then the last one will be this one. So we know from this, now we're going to convert this binary to hex, right? So what is this in hex? So it means here 1 is not present, 2 is present. So the answer for this one is 2. So here our answer is gonna be 2. I know this one is a 7, but anyway, so it means 1 is present, 2 is present, and 4 is present, 8 is not present. So it's 1 plus 2 plus 4, 4 plus 2 plus 1 is 7. So this becomes a 7. Then here 1, 2, 4. It's a 5. This is a 5. 5, 7, 2, 16. Okay, let's just see if we on the same page with this one. 5, 7, 2, 16. So just for that, you get, this is so easy. Just for that, you get 18 marks. Okay. But anyway, I prefer that because it's the easiest, right? But I think in the past, okay, I came with this one. Remember, I like this one because we learned these things from high school. So hence I say this is the easiest. And again, even if you don't have a calculator, you can just use this, right? Then there is a second method. I know your textbooks will be teaching you things like this one. There is a second method. So let's just go through it. I don't really like it. I feel like it's too difficult, but let's go through it. So now, here you have your 2, 5, 6. What is the 2, 5, 6? What was the question? Was the question 2, 5, 6, 2? I don't see the 2. 2, 5, 6, 2. I'm a bit confused. Oh, sorry, here's the 2. Sorry, guys. Sorry, it's me. Yeah, okay. 2, yeah, 2, 6, 5, 2. Okay, yeah, no, sorry, it's me. So now this is what you do for that method. This is how you go about it. So I would use this one, the one that I showed you guys. Where is it now? This one, right? I would use this one. But now you still have this method as well. For those who don't want to get confused, maybe you used to this method 2562. Sharp. 2562. Here it is 2562. So now remember when you were converting to binary and stuff, right? You will start with this bit, right? So now remember here, you are no longer in binary. For example, we will have, let's say we have 52 in decimal, right? Then you will have 1, something like 2, 4, 8, 16, 32, right? So this will be, yeah, like your 2 to the power 0, 2 to the power, come on, 2 to the power 0, 2 to the power 1, 2 to the power 2, etc., right? So now, in this case, it's the same, but now instead of 2, 2 is for binary. Now you need to use octal. Control Z. Okay, you need to use octal. So this, obviously, this will be 2 to the power 3 and stuff. So now you need to use octal. So now when you use octal, this is going to be 8 to the power 0, right? Then this one is going to be 8 to the power 1, 8 to the power 2, 8 to the power 3, then 8 to the power 4, right? So now you need to know everything to the power 0 is a 1. So this will be 1, for example, 1. So I prefer to write this out. Hence, I don't like this method. I prefer that one. So this will be 1, 8. This will be 64. So everything, if you look at it, everything going this way doubles. So this was 1, it's a double, it's 2. From here, 2, 4. From 4, 8. So everything going that side needs to double. So I think here, this should be 128. Am I right? 128. And then this one will be like something like 256. 256. 256, right? So then from here, you know you have your 2, 6, 5, and 2. So now, what were we doing there? We were checking from here. What were we doing? We were multiplying this by this, right? And then this one by this second bit, and then this one by this one, and then this one by this one. This is gonna be big numbers. But yeah, that's how you do it. Let's just confirm what if we need a calculator for this or what. Okay. Yeah, okay. So here it's a 2, which is right. 2 to the power 8 to the power 0 is 1, right? So that's why you have a 2 here. 8 to the power 0 is 1. It's 2. Then, yeah. Then here 6 multiplied by 1. 6 multiply by 8. 48. 5 multiplied by 64 is 320. Then 2 multiplied by, yeah, 128. That's 128. 1, 2, 3, 4, 8 to the power 0. Okay, let's just confirm. Okay, so yeah, so the first one is this one, 2. So we're going to say, is there an eraser here? Okay, but anyway, we're going to say 2 multiplied by 8 to the power 0, right? So let's do it here. Can I just do it? Yeah. So it's 2 multiplied by 8 to the power 0, which is this one, right? But we know it's 1, right? It's basically 2 multiplied by 1. 2 multiplied by 2 multiplied by 1, right? So that caters for the first one, right? So now the second one, it's this one of 8, right? So which is 6. So here we need to say 6 multiplied by 8 to the power 1. So 6 multiplied by 8. So 6 multiplied by 8. Yeah. 48. 6 multiplied by 8 is going to be 48. Okay, 48. And then this one, the third one, it's 64. So that's 5 multiplied by 64. 640, so it's going to be 320. 5 multiplied by 64, right? Great stuff. Then the last one, 2 multiplied by 128. Plus 2 multiplied by 128. So this method, it basically just takes this octal, right? You took the octal, you took it, this method just takes this and converts it to decimal first. So I prefer this one of the binaries because you go straight to the answer, right? You go to binary, then you're going to group in first, then you will get it in hexadecimal. But now this one, you're taking it to decimal first. So now it means you need to multiply out this. So this is going to be 256. Yo, this is gonna be Let's see. We can get it though. Let's see. So it's gonna be 256 plus 320 plus 48 plus 2. Okay, this is 50. This is 370. 370 plus 256. So 256 plus 370 is going to be, this thing is boring. It's going to be 6. 7 plus 5 is it's 12. Carry 1 this side. It's going to be 6. 626. Yeah, I feel like, you see, when I say this one, it really wants a calculator. But let's see, how far are we from it? Oh, why did we get it wrong? So 8 to the power 3. So we have this one, 8 to the power 0, 8 to the power 1, right? 8 to the, so the 2 and the 8, the 320. So we didn't do this last one. 320, okay. And tab. Okay. Let's see, why didn't we do that one? So we did this one, 8 to the power 0, 8 to the power 2, 8 to the power 3. Can someone verify for us what's 8 to the power 3? 8 to the power 3.
I think it's
1024?
512.
Is it 512 or 1024?
It's not 512.
Okay,
It's 512.
512.
It's 5 o'clock.
Yeah, 512.
Okay. All right, all right. So it definitely means that your lecture was wrong here. Do you get me? So this is not 1024. Okay, I'm also wrong because I'm using my head here. So let's see. So it's gonna be 512 here, 512. Yeah, it definitely makes sense. 512. Okay. So let's see. So now we are going to say
8 to the power
wait,
4. Larry, sorry.
Yes, you were saying 8 to the power 4?
It's 4096.
Okay, so this is gonna be 512. Then 4096. Yeah, okay. I don't know how to erase this. Oh yeah, let's move it. Let's move it away. 4096, right? Yeah, 4096 here. 4096. Okay, then this one will go to 512. So here it's gonna go to 512. 512. Okay. So it's fine. So now we're gonna take this. We're going to say 2 multiplied by this 1, 6 multiplied by this 8, 5 multiplied by this 64, 2 multiplied by this 512, right? Oh, now I see. I think no, we were the ones who made a mistake. So now 2 multiplied by 512 is 1024. 1024. 5, everything here is correct now. So yeah, now we have 1024 plus 370. 1024, so it's 1394. Huh? Yeah, 1394. So it's gonna be 1394. 1394. Yeah, okay. So let's check. Yes, it is 1394. I saw something similar to that. Okay, 1394. So the 10, remember the 10 means decimal, right? Now, from this decimal, you can convert to your hexa. So remember, when you convert to hex, you're going to take that number, you're going to keep dividing by 16, right? I am not gonna do this method. This one really wants a calculator, guys. So do you want me to do it? You take this, divide by, what is it, by 16. You only keep a record of your remainder every time, right? Then whatever answer you got here, you're going to divide it by 16 again, right? You get your answer, you keep the remainder, right? Until 0 becomes a remainder. You get my, until you get 0 point something, like a number lower than 16. Then you're going to take that remainder, which is going to be your answer. Your answer is going to be in this format. It's going to start from here, coming here, and going here to the power 16. Okay, let me see if I can get my phone close by. Let's see. Okay, so from here, let's see. So now we have 1394. So 1394, that must be converted to 1394. That must be converted to hexa. So, like I said, we're going to say 1394. Then we're going to divide it by 16. So our answer, 1394 divided by 16. Just try to open the calculator. Thirteen nine four divided by 16, it's 87. 87. Our remainder. So now how do we know our remainder? We can just say 87 multiplied by 16. Then we can see that our remainder is 2, right? Then we take this 87, we're going to say 87 divide by 16. It's going to be equals to 87 divided by 16. It's 5. Our remainder is definitely 7. 5 multiplied by 8, it's 80. Huh? Am I right? 5 multiplied by 16, it's 80, yeah. So our remainder will be 7, right? Now we have 5. 5 divided by 16, we have this, right? 5 divided by 16. It's going to be 0. Our remainder, it's 5, right? So this is our answer, 5, 7, 2, 16. So our answer here will be 5, 7, 2, 16. So both these methods, they weigh the same. So I would just choose this one, especially in assignments and exams, so that they can finish in time. And this is easier because there's no need for a calculator here. Okay, guys, I'm watching the time. Let's go to the next ones. So the next ones that I want you guys to,
I have a
yes?
question. Um, so the one that I did for the assignment is like the first one that you have there, but it only have like I think 4 or 5 steps, and I saw
Yeah,
marks there's like 17. Is that enough?
yes, that's enough. Yeah. Yes, we used to argue about that one until I said no. This is an engineering course, so you actually need to take the shortest steps to get to the answer. You know what I'm saying? Because like I said, I only know this one. We used to use this one. I know this one, but it's boring because you need a calculator. Now, most of the time in these exams or tests, they used to say to us, never use a calculator. So that's why we we liked using this one. Do you get my point?
Okay,
So yeah, this one is it's good enough. It's good enough. Okay. Then from there, I talked about the sigma notation. So it's just trying to see if we can just get a good sigma notation. Sigma notation question. Okay, let's just see this one. So this is just to remind you guys, I'm not gonna touch everything. Okay, so remember with sigma notation, I said if it's like this, it's low. Low, it's a 0. B, 1, it's a high, right? So now the first thing that I want you guys to do is to convert this into a binary format. So you take your, if it has a bar, you're going to represent it with a 0. No bar, which is high, is going to be a 1. So this will be 0, 1, 1, 1. Here, 0, 1, 1, 0. So you write all this in the binary format, right? So here's the 0, 1, 1, 1, everything, right? So then this, we know it's a 7. So you're going to convert this into decimal. So this is a 7, this is a 6, this is a 15, 5, 8, whatever, 3. So these are your answers. So sigma notation is a sum of main terms. So this M represents main terms. This represents a sum, right? So you're going to put X, all the variables that are involved, which is A, B, C, D, right? Is equals to the sum of main terms. You bracket, then you put all these main terms that you worked out here. So it's simple. You convert it to binary, then you convert it to decimal. Then all these decimals here, they are 7, 6, 15, 5, 8, 3. Are you guys with me?
Hello, can you now change the sigma? Can you simplify the sigma?
No. There's no simplification here. Remember, you are just, they are saying write for us because in French, put it in a French format. So that's what they just say. So they are just basically saying, put it in another notation. So there's no, you basically like converting, you're not making the circuit to be better or something like that. So they just want you to put it in this mathematics term or notion, whatever it is. Are you with me?
Yes, I'm with you, but then on my assignment, that's the part that I'm stuck in, where I need to simplify the sigma. So I wanted to check how it's done.
Simplify the sigma. Okay, let me see. I don't think. Let's see.
On the assignment, it's on 3.2C. Unless it's me, I don't get the question.
Is this the assignment? 2 point. Simplify the expression. Where's the sigma here? Write the expression in sigma notation. You are given the expression, how many variables, how many terms. Write the simplified form of the expression as a sum of product. You may simplify using any means. Write the simplified form of the sum of product. Okay. So what is this one? How many variables? How write the simplified form of the expression you may use. All right. You are not, I see what you mean. So, but unfortunately, yeah, I can't talk about this. So this is your sum of main terms, right? This is basically your sum of main terms, right? Are you with me?
Yes.
And now, where did this come from? It came from something like this.
Yes.
All right, that's it. That's the only thing that I'm gonna say. I'm not gonna say anything else. So this comes from this. Okay, I'll mention something as well in the notes, not a problem. So let's I'll come back to you. Let's touch on Karnaugh maps quickly. Karnaugh maps quickly. So let's talk about Karnaugh maps. WX, Y, Z. Plus, let's see what did this have? So this had, is it this one? Yeah, this had ABCD. Okay, so let's do your Karnaugh maps with ABCD. ABCD. So you have A, B, C, D plus A, B, C, D plus A, B, C, D plus A, B, C, D. So what did I say about Karnaugh maps? So now there's only two ways to simplify. There's a lot, but in your case, there's only two ways to simplify a logic circuit, right? So to simplify a logic circuit, you can simplify by using a Karnaugh map or Boolean algebra. Or Boolean algebra, right? So when they ask us to plot the Karnaugh map, sometimes they'll tell us where to put the rows and the columns, right? They might say AB. Normally they like using X, Y, W, X, Y, Z. They might say WX must be your columns and then YZ must be your rows. So this is what you do. So how many? Okay, I can't say that today. Sorry, guys. Can't say that. But so your Karnaugh map here, it has A, B, C, D. So I'm gonna put A, B, C, D here. So this side will be A, B. A, B. Then this will be C, D. C, D. So I'm going to mention the ladies' question a bit here, or a pointer. So you start with this first. So we need to have 4 columns and 4 rows. So how do you number a Karnaugh map? I know all of you know now. So it's 0, 0, 0, 1. Please check. This is not 1, 0, it's 1, 1. I always say Karnaugh map is like a tennis ball. 1, 0. Then we're gonna come here. Come on. 0, 0, 0, 1, 1, 1, 1, 0, right? So before you start, before you even draw the Karnaugh map, so you're going to do it the same way you did the sigma notation, right? So wherever you see a bar, let's say this bar is on B, you're going to put a 0. No bar, it means it's a high, you're going to put a 1. So this will be 1, 1, 0, 1, 0, right? Plus, but now what does it mean by the word plus? This will be 1, 0, 1, 0, 1, 1, right? Plus 1, 1, 0, 0, plus 1, 0, 0, 1. But now why do I keep saying plus? Plus, it's a sum. Plus. What's a sum? A sum is a result of an addition, right? So now what are we adding here? We are adding products. What are products? A product is a result of multiplication. So if you take 2 multiplied by 5 is equals to whatever it's equals to is called a product. Whatever it's equals to is called a product. So if you take A, B, C, D, this is a product. If you do this, A, B, C, D, this is a product. So what is this? This is a sum of products, right? You adding products together. Remember, I also said there is SOP and there is POS. So this is SOP. There is also POS. Products of sums. But now I'm just gonna stop here of the SOP, right? So SOP format is this. Whatever you've seen till today, it's basically your SOP format. So from this, what do? We look for 1, 0, 1, 0. 1, 0 is here and 1, 0 is here. We're going to put a 1 here. So this one that we put here is going to be called a main term. So we're going to plot a 1 here. 1, 0, 1, 0, right? So we start with AB. So AB is here. It's 1, 0, 1, 0. That's why we have a 1 here. Then we have AB 1, 0. We're going to look for AB 1, 0. CD 1, 1. CD 1, 1. Here it is. We're going to plot in the cell. So here 1, 1, 0, 0, 1, 1, 0, 0. We're going to plot in this cell, right? Then 1, 0, 0, 1, 1, 0, 0, 1. We're going to plot in this cell, right? So now these are your ones. So these are your main terms from the sum of products. Okay, I think most of you guys got me now. So let's just make it simple. Let's say we need to group together. Let's just make two groups. Let's put the one here. I've never seen such a group, but let's just put the one there. Yeah, and let's put this one. So we have two groups here. So how do we group the Karnaugh map? From here we simplify. Remember what I said? You only simplify in two ways, via the Karnaugh map and via Boolean algebra, right? So it's via the Karnaugh map and Boolean algebra. Okay, great stuff. So now, via the Karnaugh map, you look for, I always say you look for things that don't change states, right? But what does it mean by that? So you need to group ones together. You always look for the biggest group. So groups, you start from 8. You look for 8 ones grouped next to each other, then 4 ones grouped next to each other, 2, then 1, right? You can look for 16, but I've never seen 16. So 8 ones grouped next to each other. So now, there is no 8 ones grouped next to each other here. We have this 4. So we're going to group this 4 together. Remember what I said about the Karnaugh map? It's like a tennis ball. So it means this 1, it's actually next to this one. It means this cell is actually this side. So this means we can group this and this together, making our second group, right? So now let's start with the first group so that you guys can understand. So now in the first group, we have A. A does not change states. A is a 1 here and it's a 1 here. So we're going to take A and it's high because it's a 1, A, right? B in this group is a 1 and then a 0. So it changes states. So we're not going to take B because it changes states, right? In this group, we still have two columns. In the first column, C is a 0. Second column, C is a 0. So C does not change state. So we're going to take it C, but it's low because it's a 0. So it's actually not C, right? Not C. Okay, and then we have C, I said it's not C. Then we have D, 0 and 1, it changes states, so we're not gonna take it. So we are done with this group, that's it. It was A, which didn't change states. Then it was C, 0, 0, which didn't change states as well. So now we're going to look at this one. So this is a 1 and a 1 grouped together. So we're going to start with AB. Remember, this is sum of products. So we're going to add sum of products. So AB, A, in this group, there's only one row, right? Which is this one in this group. So A is 1. It means A will always be 1 because it's only in this row. So A does not change states. It will be A. B, it's a not. It's B, not. It doesn't change states as well, right? Then CD, now this means that there's two columns. There's this column, the first one, and the last one. So in the first column, C is 0, but in the last column, C is 1. So we're gonna throw it away. D is 0, and D is 0 in the last column. So we're going to take D, right? Wacht net 'n bietjie, let me just confirm here. So here we have A, C naught, AC naught. Where does, yeah, AC naught for this one. So here we have A, then we have B naught. Okay, so now we're here with the columns, okay? So with the columns 0, 1, it does, yeah, it changes states. Then we have D, which is 0 and 0. So now our answer here is not D, right? D0 and D0. So we need to put D here. Then we have a not D. So like I said, there's two ways. So far, you guys know this one. But there is this as well. Where are we? I think you guys can miss that. There is exam note 1. Am I gonna find it? So there's a folder uploaded called exam notes 1. Please look at that one. It has your Boolean algebra laws and the examples, and some of the explanations are on, yeah, they are on YouTube. So please check them out. ID law, identity law, because you are gonna need to know those laws. My PC is a bit slow. Okay, any questions in the meantime while I show you this? So no questions.
Yeah, up to so far, no question from my side.
Okay. That's great. That's great. Okay. Yeah, exam notes 1. So please, guys, you need to know, I mentioned idempotent law. If I was intelligent, I was going to write it down. Idempotent, then we have identity law. We have distributive law. So I saw now, I'm not going to mention this because all these answers are here. Some of this, I've seen these questions. I'm not going to say where did I see them, but I would want to go through this. So A and A is A. This is an identity law. Yes, hello?
I saw a question like this. It says we must mention the law. So do we write the law and also this kind of equation, or we just put the law like distributive law, or we just put the equation that is equal to the distributive law?
When you simplify, like normally when you see A plus 0, let's say you're working out something, right? And then you get to a point where you see 8 plus 0. You need to write the name of the law that you used. Do you understand? Maybe this is idempotent. I'm not sure. But they are on YouTube, these laws. Check them. I think there are 3 or 4 on YouTube. It's identity, idempotent, before this difficult one, before this distributive and associative and what. There are, yeah, like here. Let me show you. So you see, like here, I had to break out this bracket. To break the brackets out is distributive law. So you just need to write the law that you used, right? Others, they used this, but I don't think they're gonna take this. This was a long time ago. So from here, AA, you see, now we know it's identity law. Is that one that I say, I put it on YouTube, it's identity law. AA, it's an A. It's basically identity law. Then here's distributive A and 1. Maybe it's idempotent. A and 1. A and 1. Do you get my point? So you need to write the name of that law. But check those two. Those videos are less than 5 minutes, 2 minutes, 2 minutes maybe. They have the name of those laws. So you can put, it's just that I've been lazy. I don't even know where's the original for this thing. But I was just supposed to write the name of the law as well here. Maybe I'll do it next semester. It is already next semester when the schools open. Yeah, but check that. And then again, there's this De Morgan's theorem. Please read, guys. It's not difficult. It's really not difficult. Right? You can easily Google this thing. You can easily Google this thing for what you're supposed to, answer. But anyway, here, XY, it means that you need to break this line and change the sign. So you break this into 2, then you change this sign in the middle, right? So if it was a plus here, it's going to be a multiply. If it was a multiply, so a dot here or nothing here, it simply means multiplication, right? So now it changed into a plus. We broke this line into 2, then we changed this. Even here, break the line into 2, change this, right? So if it's like this, you break the line, broke this line, changed this and changed this in between. So it was not X plus not Y plus not Z. Here it is, here's the example. Here it is. So for you to do Boolean algebra and Boolean algebra questions and De Morgan's theorem, all your answers are here in this exam notes 1. They have not been asking you these difficult ones like distributive law, right? They've not been asking you those things. They've not, I think now they are starting to say you must prove if these things are the same, right? So now when they say prove, it's then that you need to know all of these things. All of these 12 laws, they are 12 in total, all of these 12 laws. You need to know, but you can just if you practice it, you can just always open this document and then always see, and then you'll get it right as you go on. Like you see A plus not A, it's a 1, but A and A plus A or A is an A. I do explain these things, that this one obviously it comes from, I can't talk about that because now that's in your assignment. Do explain it. If this is an OR gate, what's happening here, right? So you can also think in that logic. What if I'm using a gate? Pretend this is a gate. All of these things, all of these laws, they come from a gate. So now there's a gate that gives you, if anything, it's a 0, it gives you a 0. But I'm not gonna go into that. Yeah, but there is a gate that does that. It's there. We touched on it when we're talking about the gates. Touched on it. We even did some truth tables. I'm not gonna say anything. Do you get my point? So we touched on it as well. So I expect you guys to know it at least. We talked about how do you break, right? Distributive law. The distributive law, so you guys know it as well. Yeah, okay. So I think we are done. Is there any questions? I'm checking the time as well. Any questions from anyone? Okay. Okay, guys, I guess there are no questions then. If there are no questions, yeah, good luck with the assignment. Any more questions, please, you are welcome to email. Then I will upload maybe something related to the question or a similar example on my UNISA.
Okay, thank you.
All right. Okay, guys, have a lovely day. I'll see you guys. We'll talk again. Yeah, you can email me if there are any questions, not a problem.
Thank you, Larry.
All right, cheers, bye.
Bye.
Okay, cheers, bye.
Bye.